Hey everyone, welcome to lecture 6 of CSE 4635. In this lecture, we will be starting our formal discussion on servlets. And the way we have designed this lecture is first we will go ahead and do a brief introduction to servlets. Then we will take a look at the lifecycle of servlets. Next, we will take a look at a brief overview of HTML forms. And finally, we will take a look at how a servlet works by writing a very simple program. Okay, so let's begin. So let's see what a servlet actually is. A servlet is a class that is used to extend the capabilities of servers that host applications accessed by means of a request-response programming model. This request-response programming model here basically implies that we are talking about our HTTP server request-response protocols, right? So although servlets can respond to any type of request, they are commonly used to extend the applications hosted by web servers. For such applications, Java Servlet technology defines HTTP-specific servlet classes. So this is the definition that has been given by Oracle. To put it simply, a servlet is simply a Java file which is capable of taking client requests, process the information that has been given by the client, and create an appropriate output and send back the response to the client in the form of a web page. Okay, so basically, servlet is just a simple Java class that has some business logic inside it to process the request that the client has sent to us, and it basically performs some operations to process that request and send back a response back to the client in the form of a web page. Okay. Before moving on to further discussion about servlets, let's have a little bit of a history lesson first. So, at its inception, when the use of internet was popularized, people did not really require any dynamic content. They were only satisfied with static content on the internet. Okay? But gradually, obviously, the need for dynamic content arose, which led to the use of CGI, or Common Gateway Interfaces. CGI, or Common Gateway Interfaces, are essentially external programs or external applications which could handle dynamic client requests. When we say dynamic client request, what we mean is that imagine something like this. You have a client who wants to know the addition of two numbers, and he is passing these two numbers as input to a web application. Now, the web application has to perform the addition of these two numbers and then give the output back to the client or the customer, right? Now, obviously, this is an example of dynamic content because depending on the numbers that the client has inserted, the output will vary, right? Now, static content or static content-based web servers obviously cannot handle such requests. And so, in the earlier days, web servers would use CGI-based technologies, okay? So if we look at a CGI-based web server here, imagine that I have a client, and this client is passing on our request that needs to be handled by a CGI program called CGI1. Okay, so when the client sends this request to the server takes this request and spawns a child process for the CGI1 application or the CGI1 program. Okay, now it is entirely possible that a web server has multiple categories of request, and so it will need multiple types of CGI programs to handle those multiple categories of requests, correct? So now, suppose I have another client which is making a request that would require another CGI application. In this case, we are considering that the name of the CGI application is CGI2. All right. So when the client sends this request to the web server spawns another child process for the CGI2 program. Okay. Now, imagine that I have a third client who is making a request for the same CGI1 program that I had already used earlier. Okay. In this case as well, the CGI-based web server will spawn a third child process, and that third child process will be used to call the CGI1 program again. So the main takeaway here is that for each new request that is coming to the web server, a new child process is being spawned, right? So even though I have a request for the same CGI program here, in this case CGI 1, I had to spawn two individual or two separate child processes for them, right? So this is essentially the lifecycle of a CGI-based web server. Now, if you've been following along, you can already realize that there are some problems with CGI. So first, when a server receives a request that accesses a CGI program, it must create a new process to run the CGI program and then pass to it via environment variables and standard input every bit of information that might be necessary to generate a response. So essentially, whenever we receive a request, we have to spawn a new process, and inside that process, we need to pass all the information that will be necessary to generate a response. Now, creating a process for every such request requires time and significant server resources, which limits the number of requests a server can handle concurrently. So imagine that I have a surplus amount of people accessing my server and sending requests for processing. Now, if I am spawning a new process for each new request, then obviously my server will be jammed and I will not be able to serve as many requests as I could potentially could if I was not using CGI and instead using some better technology, right? So a CGI program cannot interact with web server or take advantage of the server's abilities once it begins execution because it is running in a separate process. So for example, a CGI script cannot write to the server's log file because it is an entirely different process or an entirely different program that is simply being called by the server or by the web container and not exactly a part of the server itself. Okay. So obviously we needed a alternative to CGI programs, right? Now comes Java Servlet. A servlet is a generic server extension, as we have already defined in our first slide. It is a simple Java class that can be loaded dynamically to expand the functionality of our server. It replaces CGI programs and is similar to a proprietary server extension, except that it runs inside a JVM on the server, so it is safe and portable. All right? Unlike CGI programs, which uses multiple processes to handle separate programs or separate requests, servlets are all handled by separate threads within the web server process. This means that servlets are also efficient and scalable. So essentially, whenever a new request is received by the server, instead of spawning a completely new process, the server simply hands the responsibility of handling this request to the web container. Again, we will see what a web container is later on. And the web container, instead of spawning a separate process for that request, it simply spawns a thread which handles that request. Okay, so this ensures that we are properly utilizing all the resources at our disposal on the server side. Servlets are portable, both across operating systems as we are used to with Java and also across web servers. So since servlets use Java language, it has the same portability advantage as Java itself. All major web servers support web servlets, so that is another huge advantage when it comes to using Java servlets, right? So let's see a diagrammatic explanation of what we have just explained here, and this will become much more clear. So in this diagram, you can see that we have a Java-based web server here, which is running a single main process. And inside this main process, we have our JVM, which is handling the servlets that we have in our server. So in this case, we have two servlets for handling two separate categories of requests. We have servlet 1 and we have servlet 2. Now, imagine that we have an incoming request for servlet 1. So as you can see from the diagram, this request is spawning a new thread in our main process by our main process, and this thread is basically calling the servlet that we have here. Next, we have another request incoming for servlet 2, and this also spawns another thread that is calling or that is using the servlet 2 that we have in our server. Now, we have a third request, but this time this request is coming for our servlet 1 again. So instead of creating a separate process, you can see that we are simply creating a new thread here, which is calling our servlet 1. So from this, you can understand that we have a single process running in our application server, and the single process is basically generating a new thread for each new request that is coming to the server. All right, so this is different from our CGI-based web server, where each new request spawned a new process on its own. So in this way, since we are simply multi-threading here, we are not wasting any additional resources for handling our incoming new requests. All right. Okay, now let's take a look at what get method and post method means. So we know that whenever a client connects to a server and makes an HTTP request, the request can be of several different types called methods. We have methods like get, post, head, put, delete, and so on, right? For now, we know that we will be focusing on get and post because these are the most frequently used methods. Okay, so at first, let's take a look at what the get method does. Get method is designed for getting information, for example, a document, a chart, or the results from a database query. The get method can include as part of the request some of its own additional information that better describes what to get. For example, an X and Y value for a dynamically generated addition, right? This information is passed as a sequence of characters appended to the request URL in what is called a query string. URL containing this extra information can be bookmarked as well. So again, if we are trying to get the value of addition of two numbers, for example, x and y, then the value of x and y is simply appended to the URL of the request. All right. Servers usually limit the length of URL and query string to 240 characters. So if you want, you cannot use or you cannot pass too big of an information by using the get method. All right, it is limited to 240 characters. Get method should not be used to pass sensitive information like when placing an order, updating a database, passing explicit client information, etc. So obviously, since this information will be appended to your request URL, you do not really want to pass sensitive information to your through your get method. All right. For that, we will be using the post method, as we will be seeing later on. Another thing, if unless explicitly mentioned, any kind of client request uses the get method by default. All right. If you want to use a separate category or a separate type of method to handle that client request, you need to specify it in your web application, which we will be saying how to do that later on. Now let's take a look at the post method. So a post method is designed for posting information, for example, a credit card number, some new chart data, or information to be stored in a database. It uses a different technique from get, as in some cases, a client may need to send large pieces of information. So in cases where a client needs to send large bits of information to the server, it is better to use the post method because unlike get, post method does not have any limitation on the amount of information that you want to send. A post request passes all its data of unlimited length directly over the socket connection as part of its HTTP request body. Okay? The exchange that is happening here is invisible to the client. Unlike get method, the URL does not contain any information. So if you remember, the get method appends those additional information to the request URL, right? But in case of post method, the URL does not contain any information. A post method can be used to pass sensitive information to the server. So information like your bank credentials and so on can be passed to the server by using the post method in a very secure way. So when it comes to which method you should choose for sending requests from the client to the server, as a web developer, you can choose any method, right? There is only one major difference between these two. And the major difference is that there is no limitation when it comes to the post method when you are sending large bits of information. And unlike the get method, the post method does not append the additional information to the URL, so it remains hidden from the client view, and it is passed in a more secure way, right? So that is the only difference between, or the major difference when it comes to get and post methods. If you want, you can use any of these two methods in your web application. Just remember the context and understand the context in which you are using these methods. All right. All right. So before moving forward, there are a few terminologies that we need to acquaint ourselves with. First, let's take a look at a web server is again. A web server is capable of handling HTTP requests sent by the client and respond back to the client with an HTTP response, right? A web container or a servlet container or a servlet engine is essentially a component of web server which manages the lifecycle of servlets. If you're confused what I mean by the lifecycle of servlets, don't worry. Right after this slide, we will be taking a look at the lifecycle of servlets. A web container maps a URL to a particular servlet. Okay, this is done through a web.xml file or through annotations. This part we will be taking a look later on. A web container ensures that the URL requester has correct access rights. Some examples of web containers are Apache Tomcat, Geronimo, Glassfish, and so on. For our demonstration, we will be using the Tomcat web container, as you will be seeing later on. Another thing that we need to learn about is deployment descriptor. So at this line here, you saw that we said something like mapping a URL to a particular servlet, right? So when we are accessing, as a client, when we are accessing a web application, if we want to have something done, then we need to be able to call the correct servlet for our request, right? So suppose if I want to calculate the addition of two numbers, then that request needs to be mapped to the correct servlet so that I can actually get the right result that I am looking for, right? The way this is done is by using something called deployment descriptor, which is essentially a web.xml file inside our web container. Okay, this web.xml file specifies which servlet should be called for which request. So let's take a look at what a web.xml file looks like. So in this case here, you can see that we have a root element called web app, and inside this root element, we have here two elements, servlet and servlet mapping. Now, inside the servlet element, we have two sub-elements, servlet name and servlet class. So the name of our servlet is hello world in this case, and the class that we are referring to by using the servlet name is hello world class. Okay. Next, we have to map this servlet to a specific category or a specific type of URL, right? So the servlet that we are trying to map is hello world, and the URL pattern that we are trying to map to is hello world, right? So for example, imagine that our web application is named as simple servlet, okay? In that case, whenever a client hits the URL www.simpleservlet.com/hello world, then the hello world servlet will be launched. Okay, that's all that is happening here. Now imagine your project is a very big project, and so it may contain like 50 or 60 servlets, right? So all those servlet information needs to be stored here for proper mapping. Okay. Now, instead of using the web.xml file, there is another method that we can use to map incoming client requests to appropriate servlets. In Servlet version 3.0 and above, we have a feature called annotations. So instead of using our web.xml file for mapping requests to servlets, we can use annotations to do the same task. So this is a simple servlet here, and the name of our servlet here is hello world. It is extending the HTTP servlet class, but that's not important for now. Notice this line here. We have used an annotation called web servlet, and we have given it the name hello world. So just by writing this line, we have specified that this servlet is mapped to all the hello world requests that we will be receiving from the client. Okay, so whenever we type the URL www.simpleservlet.com/hello world, then this servlet will be launched. Okay, so don't worry about the code for now. We will be seeing in a more in-depth explanation of all these things when we actually look at a demonstration of servlets. The last thing that we need to learn about is var or var exploded. var stands for Web Application Resource or Web Application Archive. It is essentially a packaged file that stores all the components of a web application and can be deployed to web servers to get the web application up and running. So essentially, it is simply an archived file which contains all the classes, Java classes, servlets, and so on that can be deployed to our server for getting the web application up and running. All right. The difference between var and var exploded is that in case of var files, all the components of our web application are first packaged into the var file, and then that var file is deployed to the server for getting the application up and running, right? In case of var exploded, instead of packaging all the web components like our folders, class files, etc., we simply directly move them to our web container for deployment. Okay, this approach therefore supports hot deployment, which is typically used during development. Hot deployment means that we can change class files on the fly, and we do not have to package the whole we do not have to package all the components of the web application over and over again. Instead, we can simply change any of the individual class files that we need to modify, and then we can hot swap them, or we can essentially do hot deployment for testing purposes. So that really helps in case of development, and so it is recommended when you are developing a web application to use var exploded instead of var. Okay, again, you don't need to worry about the practical aspects for now. When we will take a look at the demonstration of servlets, we will take a look at all these things in more detail. Okay, now we move on to the crux of our discussion today, the servlet lifecycle. A servlet lifecycle can be defined as the entire process from its creation till the destruction of the servlet. The following steps are followed in a servlet's lifecycle. The first step is initializing the servlet. The servlet is initialized by calling the init method. The init method is called only once when the servlet is created, and it is not called for any request afterwards. So each new subsequent request for the servlet results in a new thread that is handed off to the doGet or doPost methods as necessary. So from our earlier discussion, we know that a client request can be of different methods like get or post or put or so on. So each of these methods need to be handled by separate methods themselves, right? So the doGet method handles get method, the doPost method handles post methods, and so on. All right. So the servlet is normally created when a user first invokes a URL corresponding to the servlet. Okay. But if you want, you can also specify that the servlet be loaded when the server is first started. All right. So when a user invokes a servlet, a single instance of each servlet gets created with each user request, resulting in a new thread that is handed off to the doGet or doPost method as appropriate. But the doGet or doPost method work is done not in the init method, but in the service method. So this is the second step. The servlet method, the servlet calls the service method to process a client request. This is the main method to perform the actual task. An HTTP servlet usually overrides the doGet and doPost methods instead of the service method. You see, an HTTP servlet is an extension of the generic servlet class. A generic servlet class usually overrides the service method. However, in case of HTTP servlet, the doGet and doPost methods are overridden instead of the service method. The service method of HTTP servlet handles the setup and dispatching to all the doX methods, which is why it usually should not be overridden. Okay, so the service method is only responsible for dispatching the request to the doGet or doPost methods as necessary. Now, if a servlet has already been loaded, instanced, and initialized, then this step, that is this service method step, becomes the first step. Okay. So what you need to remember is the init method basically just initializes the servlet, and the main task that the servlet is supposed to perform is handled by the service method in case of a generic servlet, and by the doGet or doPost methods in case of HTTP servlets. All right. Okay, next let's move on to a diagrammatic view to show how this works. So yeah, in this diagram, you can see that we have our web server here and it is receiving some requests, right? This request has been dispatched to the service method, and the service method, after determining what kind of request or what method of request it is, it calls the doGet or the doPost method. So what you need to remember is, as the developer, you only need to override this doGet and doPost methods and write your business logic inside these two methods. Okay? Another thing, when the service method calls the doGet or doPost method, it passes two parameters to these methods. One of the parameters is an HTTP servlet request object, and the other parameter is an HTTP servlet response object. The request object contains all the information related to the client request. That is, it contains the request message body and other information. And the response object is used to basically send the necessary generated response back to the client. Okay, so basically, the doGet and the doPost methods take the request object, glean necessary information from this object, and after doing some business logic as defined by the web developer, that output is um, set onto the response object, and the response object is sent back to the client. Okay. Now, the third step is the servlet is terminated by calling the destroy method. This method is only called once at the end of the life cycle of a servlet. All right. This method gives your servlet a chance to close database connections, halt background threads, write cookie lists or hit counts to disk, or other such cleanup activities. This method is only called at the end of the life cycle of the servlet. That is what you need to remember. It is not called whenever a request is processed, okay, or when the request has finished processing. It is only called when the server intends to destroy that, intends to stop the functioning of that servlet. All right. So after the destroy method is called, the servlet object is marked for garbage collection by our JVM. Okay. So this is basically how a servlet works, or how a servlet lifecycle looks like when looked from a superficial point of view. So to summarize, let's see what is happening here. At first, a client is sending a request to the web server. The web server takes this request and passes it to the web container. The web container uses the web.xml file deployment descriptor to map the client request to the appropriate servlet. Or instead of the web.xml file, we can also use annotations, as we have stated earlier. And if the servlet has not been instantiated before, then the init method will be called to initialize it. Or if the servlet has already been created earlier, then the service method will be called directly. The service method will pass the HTTP servlet request object and HTTP servlet response object to the doGet, doPost, or doX method as necessary, and the output generated by these three methods or by any method as dictated will be passed on to the client as response. Finally, at the end of the life cycle of the servlet, the destroy method will be called, which will basically mark that servlet as for garbage collection by our JVM. Okay. So before moving on to actually implementing a servlet application, there is one last thing there that we are going to take a look at, and that is HTML forms. Handling form data represented in HTML page is a very common task in web development. Using HTML forms is the most common way of getting user input through web pages. The form tag defines a form and has a number of attributes. So the form element in an HTML document is used to extract information from the users, that is, to get information from the users. So one of the attributes in the form tag or the form element is the method attribute. So in case you were wondering earlier how the client determines whether the request is going to be a GET request or POST request or something else, it is determined by this method attribute. Okay. The action attribute defines which servlet the request is intended for. So inside this action attribute, we will define the name of the servlet which will be handling that request. Okay. The form element contains other sub-elements like input, and this input element is used for collecting data. The input has several attributes of its own, like type, name, value, etc. So this is an example form in an HTML document. As you can see, we have defined the form. We have the form tag here, and we have defined its method as get. So from this, we can understand that whenever a client inserts any information through this form in the HTML document, then the request is going to be of the get method. All right. Next, we have defined the action as hello world. So what this means is whenever the client submits information through this form, the hello world servlet is intended to be called. Okay. So inside this form element, we have 3 input tags. The first input tag is of the type text, and it has a name of sample text. The second one has a type of password, and it has the name sample password. And the third input has a type submit, and it has the value submit. Okay, so if we were to compile this HTML document in a web browser, it would look something like this. So we have our form sample text here. Next, we have our sample text field here. Next, we have our password field here. And finally, we have our submit button here. Okay. Now, obviously, there are different types of input fields. Let's take a look at a few of them. So in case of text field and password field, our HTML code will look something like this. We have the input type as text for a simple text field, and our input type as password for a simple password field. So this HTML document will look something like this. We have our username and we have our password. Okay. Now, if we want to extract the information from these fields using our Java program inside our servlet, all we have to do is we have to write some code which is something like this. We have declared a username and password string, and we have simply used request.getParameter, and inside getParameter function, we have passed the name of the field that we are trying to get the value of. So in this case, for a username, the name of the field was username, so we have simply written username here. And in case of the password field, the name was PW, and so we have written PW here. Now, if you're wondering what this request object is, try to remember, in our doGet and doPost methods, we are passing 2 parameters, remember? One was HTTP Servlet request object, and the other was HTTP Servlet response object. So this request object that you see here is simply that request object that has been passed to the doGet or the doPost method by the service method. Okay. So after you get the values like this, you can do whatever you want. For example, in this case, we are simply printing those values, right? Next, let's take a look at how we can read values of the checkbox field. So in HTML, we will simply write input type is equal to checkbox. We will give it a name of language, and the value that we are assigning to it is English. Now, if we want to add another checkbox to this already existing checkbox that we have created, we simply write another input tag, type equals to checkbox. The name has to be the same name as the one before that we used. Okay, so if we want to add multiple checkboxes to the same list, then we have to use the same name for them. All right. So in this case, the value is French. So after compiling this, this is what we will get. All right. So in this case, you can see that we have the speaking language text here, and we have 2 checkboxes, one for English and one for French. All right. Now, to get the value of this checkbox, all we have to do in our Java code is we have to declare a string array. All right. Now, in this case, we are declaring a string array because it is possible that we have checked multiple checkboxes here. In this case, you can see we have marked 2 checkboxes. So we will be getting 2 values, right? So when we say something like request.getParameter language, that is, we are indicating that we are trying to get the value for this language checkbox, then we will be getting two values, right? So these two values, English and French, will be stored in this languages array, and after that we can do whatever we want with them. Okay. Next, if we want to read the value of radio button field, the HTML code will look something like this, where we simply write the name or the type as radio for the type attribute, and the name has to have the same value. Okay. If we want to specify a number of radio elements for this under the same radio tag, then what we have to do is we have to use the same name for them. Okay. So for the first value, or for the first radio button, we have given the name male, and for the second radio button, we have given the name, the value female. Okay, so this is what it will look like, and if we want to extract the value of these fields using our Java program, all we have to do is, again, simply write request.getParameter, and in the bracket, we have to specify the name of the radio button field that we have created. So in this case, we don't have to create a string array because we know that in case of radio buttons, we will always be getting only one value, right? So if we select male, female will be unselected, and if we select female, male will be unselected, and so on. Now, let's see how we can read value of a text area field. In case of a text area field, we simply have to write not the input element here, but in this case, we will be using a new element called text area. And if we want, we can specify other attributes like rows and columns for the text area field. Then we will give it a name equals to feedback, and we will close the text area element here, right? So if we create a text area field like this, then this is what it will look like in a web browser, right? Now, to extract the value inside this text field, in this case, this tutorial is very helpful. Thanks a lot. If we want to extract this value from the text field, what we have to do is we simply have to write string feedback. That is, we have to create a string type object, and we have to simply write request.getParameter. And inside the parenthesis, we simply have to write the name of the text field, right? So since we have defined the name of the text field as feedback, all we have to do is write feedback here. Okay. Now, if we want to read the value of a drop-down list or a combo box field, our HTML code may look something like this. So in our drop-down menu, suppose I want to have 4 options, one for tech or technology, one for administration, one for biology, and one for science, right? So in all these cases, what you need to remember is, again, we don't have to use the input element here. What we have to do is we have to use the select element here. Okay, so the select element basically denotes that we are trying to create a combo box or a drop-down list. So the name of this drop-down list has been given as job category or job cat. And in this case, we will have 4 options as we have already stated. And these are the values that have been given there. All right. So if we create an HTML document like this, our HTML document will be rendered in this way. So we have our job category text, that is this one here, and we have our four options here as we have defined. Now, if we want to get these values, that is technology, tech for technology, admin for administration, biology for biology, science for science, and so on, all we have to do in our Java code, we have to again declare a string object, and we have to write request.getParameter, and simply have to write job cat. So in this case, what will happen is it will return us the value of the option that we have selected from our drop-down list. Okay, so those were some of the more popular input types or different types of elements that are used in an HTML form. There are obviously different other categories of HTML of sub-elements inside HTML forms as well, but these were some of the more popular ones. So now that we are done looking at an HTML form and looking at some of the properties of HTML forms, we can move on to an actual implementation of a servlet. Okay. Okay, so the first step to run a servlet application is obviously you need to install an IDE of your choice, but preferably IntelliJ or Eclipse. For our demonstration, we will be using IntelliJ Ultimate Edition. Now, if you want, you can get the IntelliJ Ultimate Edition for yourselves as well. I believe all of you have your IoT EDU account. So by using that EDU account, you can get IntelliJ Ultimate Edition for a limited amount of time. So just Google how to get the student account for IntelliJ Ultimate Edition by using EDU accounts. You can find it on Google. Okay. Next, what you have to do is you have to install a web container. So if you remember, there are a couple of web containers that we talked about, like Tomcat, Glassfish, etc. The one that we will be using for our demonstration is Apache Tomcat. Okay. So let's see how you can, or how we can, download this Tomcat web container. Okay, so to download Tomcat, what you're going to want to do is you will go to this website, and on the left-hand side of this website, you can see that the version numbers of Tomcat has been listed here, right? So the version that we will be downloading is Tomcat 9 because I think this is the most stable version out right now. So head over to Tomcat 9, scroll down, and you will see that there is a core zip version, tar version, and so on, right? So the version that we are going to download is 64-bit Windows zip because our Windows is 64-bit, and the zip file will be enough to basically run our web applications on Tomcat, because after extracting the zip file content, we will simply be loading that content inside our IDE. So just simply download this zip file and extract it into a directory according to your preference. Okay. Okay, so after downloading Tomcat, now what we are going to do is we are going to start developing using IntelliJ. So after hitting new project inside IntelliJ, we will be given this window here. Okay, from this window, we will select Java Enterprise, and in this new window here, our project SDK will be displayed. Now, depending on the version of Java that you are using, this version number will vary. All right. So next you have build tool and test runner. So you don't need to change these options right now. Just keep them as they are and hit next. In this window, we will be selecting web profile, and again we will hit next. Now for the name of our project, we will be giving it the name that we according to our preference. So let's just give it something like simple Servlet. All right. So next we will hit finish. But notice that we have been given an error here, and the error is that white spaces are not allowed in case of artifact names. So what we have to do is we simply remove this white space for the artifact name, and then we can hit finish. Now, if you're wondering what an artifact is basically used to denote any resource that we are going to use in our project. Okay, so yeah, hit finish, and our project is going to open. Yeah. All right, so as you can see, IntelliJ has created this project for us, and we have already got some notifications. We can ignore those for now. And we have a Maven window here, which again, we can ignore for now as well. So the first file that we have here is a pom.xml file. So in this case, we don't have to worry too much about the pom.xml file. It is related to the configuration of the project. So we're not really worried about it for now, okay, since this is a very simple demonstration. Now, if you look to the left window pane here, you can see that we have a project structure created for us. So IntelliJ created the structure for us, and this is a very important structure that we need to follow whenever we are developing a web application. So under Simple Servlet, that is under our project, we have a folder called source, or SRC. And under source, we have two more folders, main and test. So under main, we have Java, resources, and web app, three separate folders. Inside this Java folder, we will be creating our servlets, and inside our web app directory, or under our web app folder here, we will be creating our JSP pages. Again, we will take a look at that later. For now, let's create a very simple servlet called Hello World. So simply right-click on Java, hit New, and go to the bottom of the list, and you will see that we have something called Create New Servlet. Yeah. So just hit this Create New Servlet and give it any name that you want. For now, we will be giving it the name Hello World, since we are essentially building a very preliminary application. And notice here that we have an option called Create Java EE6 Annotated Class. All right, so remember when we said that we can use either web.xml file or our annotations to basically denote which request should be mapped to which servlet? So if we check mark this checkbox here, essentially we will not have any entry in our web.xml file for this servlet. Instead, what we will have is an annotation that will define what that servlet is mapped to. Okay, so for now, let's uncheck it. All right, so this after we have created that servlet, now inside our web.xml file, you can see that we have an entry called servlet. Yeah, and inside the servlet entry, we have two names, two elements, servlet name and servlet class. So the servlet name that we have defined earlier has already been copied here, hello world, and the class that it is referencing is hello world class. Okay, so now you can see that we have an error here, and it says that servlet should have a mapping. Yeah. So what we are going to do is we are going to create a servlet mapping element here, and the name of the servlet is hello world, and for the URL pattern, we are simply going to write / hello world. Okay. So this means that any type of URL that has this / hello world to it, automatically the hello world servlet will be called, okay, whenever that URL pattern or that URL is hit. All right, so far so good. Now let's take a look at the class or the hello world Java file that we have created. Okay, so inside this hello world.java file, you can see that IntelliJ has automatically created a template for us. So this hello world class, since this is a servlet, it is extending the HTTP servlet class, which is available under javax.servlet.http servlet. Okay, so basically, um, since hello world is a servlet, it is extending the HTTP servlet class. And this HTTP servlet class has these two methods, doPost and doGet, which we are overriding here. So yeah, this is essentially what we have learned in our theoretical part, right? So we have our doPost and doGet methods here, which will be handling post and get methods respectively, right? So for now, remember that unless explicitly specified, all kinds of HTTP requests are of the get method. Okay, so let's write some code inside our get method for now. And what we are going to write is something very simple. We only want to print hello world, right? So let's declare a message string object called message and give it the value hello world. And then what we want to do is we want to print this message as an HTML document, right? So now what we are going to do is we are going to set the MIME type of the response object that we will be sending back to the client. So what we are going to do is we are going to take this response object here, and we are going to set content type. Inside this content type, we will specify the MIME type that we will be sending back. All right, so far so good. Now what we are going to do is we are going to create a print writer object. Okay, so print writer out equals to response dot get writer. Okay, so what this essentially means is this out print writer object will be used to write outputs to the response object that we have. Okay, so using this out object, we can write HTML commands from our Java program or from our Java file here. So what we can do is we can simply write out.println, and inside here we can use any HTML tag that we want. So for now we will be using the h1 tag, and we will be printing the message that we have defined here. So message, and finally we will be ending the tag here. So yeah, so far so good. We have our first servlet, and whenever the servlet is going to be called, we will simply get a message that says hello world. Okay, now the problem is this is not our home page, is it? This is not the home page that is going to be displayed whenever a user enters the URL for our simple servlet web application here. So what we need to do is we need to create an index page, right? So for creating this index page, what we are going to do is under this web app file folder here, we will be creating a new JSP page. For now, just consider that JSP file is the same as an HTML file with some additional functionality, which we will be talking about later. Okay, so let's give it the name index. So yeah, here we have our index file. Now inside our index file, let's do some modifications. So let's give it the name simple servlet web application. All right. Next, let's print some message here. Yeah, let's use this h1 tag again. All right. And here we will simply write something like this: simple servlet web app demonstration. All right. So far, so good. And now we want some kind of link in this index page, which will point to the hello world servlet that we have created. Yeah. So let's write that now. Let's define an h2 header. And here we write to invoke the hello world servlet. Click. And then what we will do is we will create a reference to that servlet. So for that, we can use the a tag. And this a tag will have an href attribute. And inside this href attribute, we will be mentioning the servlet that we want to call. Okay. All right. So now, whenever this index page is loaded, it will have a hyperlink called here. And this hyperlink will redirect us to this Hello World program, right? Okay, so far so good. Now what we are going to do is we are going to build our project and hope for the best and hope that there is not going to be any error here. All right, so build completed successfully. Now what we are going to do is we want to deploy this web application to our Tomcat server, right? So for that, what we have to do first is we have to create a WAR file, remember? So here we will click build again, and then we will hit build artifacts. And inside artifacts, we will select simple servlet war exploded. So if you remember, war exploded is suitable for development purposes. So we will be selecting war exploded here and not war. All right. So we will create the war exploded file. All right. It has been built successfully as well. And now what we want to do is we want to deploy that war file inside our Tomcat server. But hang on, we haven't really defined a Tomcat configuration for our project yet, right? So for that, what we are going to do is we are going to hit add configuration here, and then we will be given this window, right? Inside this window, you can see that we have a plus sign here. So hit that plus sign, scroll to the bottom of the list, and you will see that we have an option here called Tomcat Server Local, right? So hit that Tomcat Server Local here, and then since I have already used Tomcat before, since I have used Tomcat before in another project, it has all automatically been selected for me here, right? So for you, it might not be selected automatically, in which case what you have to do is you simply have to hit configure here and scroll, and from here you have to basically add a application server. And for the Tomcat home, you will be selecting the directory for which under which you have extracted the Tomcat zip file that you have downloaded, right? So in this case, I have kept it under program files of my D drive, and so I will be selecting this folder here. Okay. So remember, you have to select the Apache Tomcat directory, not the bin directory. Okay. So yeah, after you've hit OK, you will hit OK here, and your configuration will be complete for Tomcat. But now you have to configure some other things as well. So under the server tab, you will see that you have some other options as well. So you have options like after launch, which web browser you want your application to launch. So in this case, I will be selecting Chrome, and the URL pattern of your web application is shown here as well. You don't need to change it. And here, if you want, you can change the port number at which your application will be launched, right? So in most cases, what will happen is Windows uses this 8080 port number for some other services. So what you are going to want to do is change these port numbers to something else. So for this example, let's use 8083 as our HTTP port number. Similarly, your JMX port number may also be used by some other program, in which case simply change this JMX port number. Okay. Now you will see that we have a warning here. It says that no artifacts have been marked for deployment. What this means is that we have not selected any war file or any war exploded file to deploy in this Tomcat server. So to fix that, simply go to the deployment tab here, hit this plus sign, hit artifact, and you will be given the option to basically denote which file you want to deploy. So we will be selecting war exploded, hit OK, and yeah, as you can see, that error that we had earlier is gone now. So you don't have to change any other thing on the other tabs here. You simply hit apply and OK. All right. So now we have the option to run our web application inside our Tomcat server. So let's run it and see what happens. It takes a while to compile, so let's hold on. All right, so yeah, our web application is working, right? So as you can see, this is the URL that refers to our web application. And if you remember, we had a line on the index page that said simple servlet web app demonstration, and we had a hyperlink, that is this link here, which would point us to the servlet that we had created, that is the Hello World servlet, right? So let's click this link here and see if it takes us to our Hello World page. So yeah, it has taken us to our Hello World page, and look at the URL now. It is using /hello world to basically call our Hello World servlet, right? So yeah, that is how we can create a very simple project. But that was a very simple project, right? We are not really happy with the project that we have created. Let's do something more interesting. So inside our index page, inside our index page here, let's create a simple form, okay? Inside this form, let's define the method as get for now, and define some other information like the action. Yeah, so when we say action equals to hello world, if you remember, this means that the form information is going to be sent over to the hello world servlet, okay? So let's skip it hello world servlet for now. And inside this, we will be creating an input field. The type of the input field is going to be, oh, let's give it number. Let's give it the name number1. Next, we create another input field. Give it the type number again, and give it the name number2. Now, to pass this information to the servlet, we will be creating another input button here, which will be of the type submit, and let's give it name calculate. So essentially what we're trying to do is we are trying to calculate the summation of these two numbers, okay? All right, so suppose we do not want to send this information to the hello world servlet. Instead, what we want to do is we want to create a new servlet and pass this information to that new servlet, yeah? So for that, what we are going to do is we are going to right click on Java, and again, we will hit create new servlet. And for this servlet, let's give it the name calculator, okay? And now, instead of unchecking this tick box, let's keep it checked, all right? And let's see what happens. Okay, so our calculator.java servlet has been, our calculator servlet has been created. And notice that we have an additional line here. So this additional line is basically denoting that this is a servlet, which is of the name calculator, and any request that is referencing the /calculator link, that request is going to be handed over to this calculator servlet. Okay, so since we are using annotations here for mapping this servlet, if you look at the web.xml file here, you can see that no servlet element has been created for the calculator class, right? Okay, so that's nice. Now inside our doGet method, let's actually calculate those values, right? So for that, what we are going to do is we are simply going to declare two numbers int num1, num2, and we will be creating another variable for storing the summation of those two numbers. So num1 is equal to request dot get parameter, and inside this parameter function, we will write the name of the parameter, or the name of the field from which we are trying to get the value. Okay, so now you can see that we have an issue here. The issue is this request.getParameter function is going to return us a string value and not a integer value. So what we are going to do is we are simply going to convert this into an integer type by using the integer.parseInt method, and yeah, there you go. The problem is gone now. We will be doing something similar for our second number. And finally, we will be calculating the value of summation of these two numbers. There you go. Now what we are going to do is we are going to print this summation on our web page, right? So let's create a print writer object again. So yeah, we have created our print writer object. And inside this, by using this print writer object, we will be simply printing the result inside our web page. So let's create an h1 tag again. The value you are looking for is, and then we will simply give sum, and there we have our web page created there as well. All right, so now let's go back to our index page, and in this index page, instead of for this form, instead of the action hello world, we will be giving it calculator. Okay. All right, now if we run this program, let's see what we get, right? Restart server. So again, it is compiling in the background. We will have to wait for a bit. All right, now that the build has been completed, let's see what we get. All right, so yeah, as you can see, we have our two input fields now. Let's give two numbers and hit submit. Okay, we have an error here. Let's find out what the error is. Okay, so for some reason, our calculator mapping is not working here, right? Okay, so I figured out the issue that we were having. So inside this web servlet annotation, we have to mention the URL mapping as well. So if we go back to our index page, you will see that when we have typed action equals to calculator, it gives us a warning, cannot resolve file calculator, right? So all we have to do here is inside this web annotation, we have to define our URL pattern attribute as well. And for this URL pattern, we are going to use /calculate. Okay, so all right, let's change the action to calculate here. All right, so we have our URL pattern here as well. So good. If we wanted, we could have used any other URL pattern as well. We could have written here /a, and in this case, all we would have had to do is write action equals to a, right? So it basically depends on what you want to type here. So anyway, now our program should be working. Let's restart our server and see if it works. So it's building. Okay, it has been built successfully. Now let's go back to the home page. Takes a while to load, yeah. So we have our two input fields here. Let's give 4 and 6. Let's submit. All right, so yeah, the value you are looking for is 10. So we can understand from this that our web application is working correctly. Now, look at something interesting here. Since we were using the get method, you can see that the values of number 1 and number 2 have been appended to the URL here, right? So number 1 equals to 4, number 2 equals to 6, right? So if we want, we can change it from here as well, the value, and we will get the updated result. So this is a special characteristic of the get method, right? Now let's perform an experiment. Let's change the method to post, okay? And now we need to have this block of code inside our post method. So let's just copy and paste it there. Sorry about that. Okay, so now let's try running it again, and let's see what happens. Still building. Okay, it has finished building. Now let's reload our application. Takes a while. All right, it's there. Now let's give 4 and 7. All right, we got our answer, but now if you look at the URL, you can see that the value has not been appended to the web URL here, right? So yeah, that was a very basic demonstration of how a web servlet web application works by using servlets. Hopefully you were able to understand everything here, all right? Now, if you have any question regarding the theoretical part that we discussed or the practical implementation of servlets that we have shown here, let me know in our live class tomorrow, and I will try to answer your questions to the best of my abilities. All right? So take care, stay safe. I will talk to you guys tomorrow. Okay?